Okay, so 3.1, exploring probability. We're going to be going through the differences between odds and probability. You guys ever heard, like, there's like odds for something, or like odds in Vegas, or probability. Usually people kind of think they're the same thing, but they have kind of particular definitions. So the odds, I'm just going to make this as simple as possible. Odds are usually going to be like separated with like dot dot. So it's going to be like some number dot dot some other number, and it's going to be favorable dot dot unfavorable. I'm just gonna leave it like that because you can get like a really big definition if you want, but like I think it confuses things. Favorable to unfavorable. Okay, and then probability will be usually written like this, and it will be favorable over total. All right. So what do I mean by that? So if I said like you were in Vegas and it said like what are your odds of winning, like a horse race or something, you might say that it's 2 to 5, right? Maybe you'd have something like, you don't have to write this down, but it'd be like 2 to 5. What that would mean is that you have 2 chances of winning, 5 chances of not winning. 5 chances of not winning, right? Okay, so now probability is a little bit different, right? So probability is going to be 2 chances of winning. But then, do you know, like in the situation I had above here, what your total would be? I think you were 7. It would be 7. Because if you've got 2 chances of winning and 5 chances of not winning, in total you'd have 7. So that's it. This is like the big idea. You can like go back and forth between these two things, between odds and between probability. You know, if they give you odds, can you figure out probability? If they give you probability, can you figure out odds? That's kind of it for like the next 2 lessons. And yeah, so it's not too bad, but I just find, I don't know, people get confused by it. So we'll do a bunch of examples. Okay. So use these numbers to answer the following questions. Okay, so the number is 1 to 20. What's the probability of picking a prime number? Okay, do you guys remember what prime numbers are? They're numbers that are only divisible by itself and 1, but 1 doesn't count. So a prime number, the first prime number is 2, because it's only 2 times 1 and that's it. There's no other numbers that you can multiply to get 2. 3 is a prime number, because it's just 3 and 1, that's it. What about 4? No, because 2 times 2, that doesn't, so it's not just 4 and 1. So that's not a prime number. 5 is a prime number, it's just 5 and 1. 7 is a prime number. 8's not, 9's not, 10's not. 11, just 11 and 1, that's it. 13 is a prime number. 17 is a prime number. And 19 is a prime number. All right, so how many do we have there? 1, we got 8, right? So 8 over 20, that's it. Technically, that wouldn't quite be it. You don't usually leave it written as 8 over 20. You would simplify that. What goes into 8 and 20? 2. 2, oh, I guess we could live in 4. Let's do 4, right for that. 4. Okay, so 8 divided by 4 is 2. 20 divided by 4 is 5. So you can say the probability here, probability is 2 over 5. 2 over 5. Or, another way of writing it is you punch it in your calculator and go 2 divided by 5 and get it as a decimal. This would also be 0.4. That's also a way of writing probability. Or, do you guys know what 0.4 is as a percentage? 40, right? So times 100 if you want to, or 40%. You can see probability written in all those different ways. You can see it written as a fraction, a decimal, or a percentage. Okay. Now, what's the probability of picking? Oh, that's sorry. That's what we did. What's the probability of pulling a number divisible by 3? Okay. So again, I just actually write down what they are. So divisible by 3. So 3 is divisible by 3. So 6, 9, 12, 15, 18. All right. So how many we got there? 6 again. Seems a bad example. All right, so, oh, never mind, the other one's 8. All right, so 6 over 20. I can divide those both by 2. So this ends up being 3 over 10. 3 over 10. 4. 0.3. 4. 30%. All right, what are the odds? So what I would do when you guys are doing these questions, because it's not always as obvious as this, as soon as you see the word odds, like maybe underline it, highlight it, you know, some of you guys have strategies of doing that. Just because that's a particular meaning, right? So odds in favor of getting an even number. Okay, so even, all right, so even numbers, how many do we have here? You're going to have 10, right, in total here. We probably don't even need to circle those ones. There's going to be 10. So remember, for odds, odds is going to be favorable, dot, dot, unfavorable. So 10, yeah, 10 to 10. You don't typically write odds as like a fraction, like 10 over 10. You don't usually write odds that way. It's usually with a dot dot. And you can also simplify these though. So 10 to 10, what could that simplify as? 1, 1, right? Have you guys ever heard that kind of thing? Like you got 1-to-1 odds, 2-to-1 odds, like in a game or something? That's what they're saying. You got, like, if it was 2-to-1, there'd be 2 chances of winning, 1 chance of losing. Okay, so that's the odds in favor of getting you an even number. What are the odds against of getting a number divisible by 5? Okay, so that's going to require that we know all the numbers divisible by 5. So that's going to be 5, 10, 15, and 20. A good way to do these ones is write the odds in favor of getting one divisible by 5. So I'd say there's 4, dot, dot. Is that going to be 20? 16, right? It's everything left. So it's 4, dot, dot, 16. Right? That's also considered a complement, remember? From other units. So, yeah, 4, dot, dot, 16. Okay, so the odds against, right? The odds against here is just going to be flipped around the other way. Right? So this would be in favor of. So the other way of looking at it is 16, dot, dot, 4 would be the odds against. Maybe let's write down what we did here too. Odds for is what that first one was. Okay, and then last thing though, you'd want to simplify this again. So what do 16 and 4 both, what can you divide them both by? 4, so 16 divided by 4 is 4. 4 divided by 4 is 1. So your odds against getting a number divisible by 5 are 4 to 1. Let's do this one. What are the odds of the Oilers winning the Stanley Cup? So this question is 0. 0 to what? It's got to be odds, not probability. Okay, so suppose at the beginning of the season, hockey pundits give the Edmonton Oilers a 25% chance of winning the cup, right? So express the probability that the event will occur as a fraction over 100. So how can you write 25% as a fraction of 100? 25 over 100. That's what a percentage is, right? When you say 25%, you really mean 25 over 100. Okay, describe the complement of this event. You guys remember what complement meant? It was like the prime symbol when we were doing this unit before. Complement meant everything but, right? So if you've got a 25% chance of winning, the complement would be your percent chance of losing, right? It's everything but that percentage. 75 over 100. Oh, that's what we did for the second one. Write the probability of the complement as a percent and fraction over 100, so that's what we just did there. All right, D. The odds of the Oilers winning the odds of the Oilers winning is their probability of winning as a percentage divided by their probability of not winning as a percentage. Write the Oilers' odds of winning as a fraction and reduce the fraction. Finally, write those odds as a ratio. So probability of Oilers winning the cup, what did we say that was? 25%. What did we say the odds of them not winning it? Yeah, 75%. If you reduce that, what would that reduce down to? They both divide by... They do both divide by 5, but 25 is probably a bigger one we could divide them both by. So we divide them both by 25. This ends up being 1 over 3. But typically, like I said, the way that we write odds would be 1 to 3. All right, so now the other way around, right, is the complement of this event is the odds of losing, right? So the odds against is the probability of them losing, right, as a percentage, by the probability of them winning as a percent. Right, the odds of others losing. So this is just the other way around, right? So you're going to have 75% over 25%, which would be 3 over 1. Or as odds, it would be 3 to 1. 3 to 1 odds.